I'm Jasmine Jeshi Shija, Assistant Professor from the EC Department from RCT College of Engineering and Technology. Now we can see what is meant by convolution. Convolution, it is the mathematical way of combining two signals to form a third signal, and it is also used. It is the most important technique in DSP because convolving the two sequences in the time domain is equivalent to multiplying the sequence in the frequency domain. It is used for determining a system output given an input signal x of n and system input response h of n. And now we can see the types of convolution. There are three types of convolution. First one is linear convolution. It is classified into graphical method and cross table method. And circular convolution, it is classified into concentric circle method and matrix multiplication method. And the last one is section convolution. It is again classified into overlap save method and overlap add method. Now we can see what is meant by circular convolution. It is a periodic convolution and the length of the two sequences must be same, and here we are taking the inputs as x1 of n and x2 of n, and x3 of n is the output. Therefore x3 of n equal to x1 of n convolution x2 of n. And now we can see what is meant by zero padding. If the input sequence length are not equal, we should add zeros to equivalent the length of the sequence. This is the concentric circle method. First one is concentric circle method. Here, in the case of concentric circle method, we are representing the two circles in the form of circles. Two sequences are represented in the form of circles. The outer circles represent the first sequence and the inner circle we are representing the second sequence. While we are representing the first sequence, here the sequence are represented by using the anti-clockwise direction in the outer circle, and the inner circle, the second sequence is represented by using the clockwise direction. Now you can see some other problems. Now first one is perform the circular convolution of the following sequence x of n. They are given the sequence and h of n. We want to find the value for y of n equal to x of n convolution h of n. Since we are having the two sequence, first we want to see whether the length of the two sequences are same. Now we can represent the two sequence by using concentric circle method. In the first circle, in the outer circle, here the two sequences are represented. In the first circle, the sequence are represented by using in the anti-clockwise direction, and in the inner circle, the second sequence is represented by using the clockwise direction. It is represented in clockwise direction. While we are representing, after representing the particular position, the sequence are multiplied in that corresponding position, and finally they are added, and we are finding the sequence as y of 0. It is 13. In the second step, here the outer circle is keeping as such, and the inner circle, here we are rotating once in the anti-clockwise direction, and same as the previous one, we are again multiplying the sequence in the particular position, and finally we are adding the sequence, and that represents y of 1 and y of 3. Here also the first sequence, it is keeping as such, we are keeping the sequence as such, and the second sequence, the inner circle, it is moved once to the anti-clockwise direction, and finally we are adding the sequence to that corresponding place, and finally we are getting the sequences y2 equal to 11. And the last step is y of, that is for step 4. Here also the outer sequence, it is keeping as such, and the inner sequence, it is rotated once to the anti-clockwise direction, and finally we are multiplying the sequence in their corresponding positions, and finally we are adding and we are getting the sequence, and at last, after getting all the sequence y of n can be represented by using y of n equal to, we are representing 1 by 1 by using comma marks. This is about the concentric circle method. I think you are more clear. Again we can see one more sum. Here also perform the circular convolution. They are given two sequence x h of n h of n. We want to find the value of y of n equal to x of n convolution h of n. In step 1, here also we are having two sequence. Since we are having two sequence, the sequence are represented by using, the outer sequence are represented by using the represented in the anti-clockwise direction, and the inner sequence is represented by using the clockwise direction. Here same as previous one, we have already seen, by using the same concept we are just multiplying the sequence in that corresponding positions, and finally we are adding and we are getting the value as y of 0. And similarly for y of 1, the inner circle is shifted once, that is it is moved to the anti-clockwise direction once, and we are multiplying, and finally we are adding, we are getting the value as y of 1. Similarly for y of 3 also, here The third sequence, that is in the step 3, the inner circle is again rotated once in the anticlockwise direction, and the corresponding sequence are multiplied in that particular position. Finally, we are adding, we are getting the values y of 2. And in the fourth position, here also the particular sequence, that is the first position, it is again, that is the inner circle, it is again moved once and shifted once in the anticlockwise direction, and finally we are multiplying the whole sequence and adding, we are getting the values y of 3. At last we are writing all the sequence in the sequential order, and we are writing as y of n. That's about the concentric circle method, and I think it is more clear. Next one is matrix method. In the case of matrix method also, they are given two sequence, that is x of n and h of n. Here h of n, it is represented by using matrix representation. Here we are representing by using column matrix. In the first column, the second column, the first last sequence is shifted to the first, and remaining we are writing as such from the second column is the second row itself. In the third column, the last sequence is again moved to the upper position, and remaining we are writing as such. And the last column, it is again moved to the top, and finally we are writing as such. And x of n, it is again written in the given order, and finally we are performing the matrix multiplication, and at last we are getting the sequences y of n. That's all.